Hi, Bob. Good morning.
Hey, good morning, Barbara. Good to see you.
Nice to see you too.
Yeah. And you're here in Houston?
Yes,
Yeah.
yes, we.
Okay. I know you were traveling, but yeah, typically I'm always doing this with Paulo and he's all over the world. So it's kind of nice to have somebody who's actually in the same
In the
time zone.
same time zone, right?
And I know we have participants from all over the world. Oh
Yeah,
yeah,
I can
good
see them
morning.
logging in.
Yeah, good
hmm
morning, good evening, good afternoon,
Good
good.
afternoon to everyone.
Yeah,
hmm
yeah, absolutely.
Okay, I know this is a very interesting topic, and normally we run a little bit over the hour. So should we start now? That way we can try to
Yeah,
stay in the
yeah,
hour range.
yeah,
Let's see
absolutely,
people.
Barbara.
Mhm. Perfect. So, hello everyone. Thank you so much for joining us today. Let me introduce myself. I am Barbara Vasquez Isla. I am Director of Technical Solutions at GMI Americas. I have had the opportunity to work with several customers in North America and Latin America, helping them in their design of intrinsically safe systems. And I'm thrilled here to be today with Bob Johnson. For some of you that haven't met Bob yet, he has several decades of experience in electrical installations in hazardous locations. He's also an instructor for Compex as per IECEX, and he's owner of Source IEX, who is a distributor partner for us here in Texas. So thank you so much, Bob, for joining us here
Yeah,
today and be
thank
our
you,
key
Barbara.
speaker.
Yeah, thank you.
So let me go a little bit over who is GMI for whoever's joining today that haven't get too familiar with the company yet. So GMI is a Italian company that designs and manufacture functional safety devices, um, just safety relays as well as intrinsically safe barriers. These type of equipments are being utilized on safety applications such as emergency shutdowns, fire and gas systems, burn management systems, high integrity pressure protection systems, and many other applications where they are the interface between the field device and the PLC or DCS. We work mainly in the process industry, right? So oil and gas, petrochemical, chemical, pharmaceutical applications. Um, and the company has 40 years of experience specifically on intrinsic safety. Um, so yeah, on the next slide, we'll see that we're Italian company, but we have global presence. So like Bob was mentioning, I work in the Houston office, GMI Houston, which is the headquarters for the Americas, and we have several offices as well in Asia, in Middle East, of course, Europe, and we partner with our distributor partners such as Bob today. Mhm. Something that I find very interesting on the GMI products is all of them are being manufactured in Italy, and it is a state of the art production facility. And every single product that GMI manufacture is being tested completely before it leaves the facility. That allows us to provide you, the user, a 5-year warranty. That's something I find very interesting in the market nowadays. So we have that 5-year warranty for you guys. Mhm. As I mentioned, we are a Italian company, so we're a European company. So all our products will be ATEX and ICX from the get-go, but we have global presence. So we also carry the North American approvals, such as UL, FM. We also carry Chinese approvals, so from India, in Metro for Brazil, and of course TUV for functional safety, and many of our products will be DNV for marine applications.
Oh, sorry.
Hmm. Yeah, no, no problem.
There goes.
Yes, and this will be the range of our products. So like I mentioned, intrinsically safe isolators, seal-tree safety relays, seal-tree signal conditioners, seal-tree power supplies, I/O multiplexers, termination boards, which have the connector ready for that DCS card, seal-tree heart multiplexers, seal-tree and intrinsically safe surge protectors, and our X1 series, which is a compact solution that provides also intrinsic safety or functional safety seal-tree relays with the built-in connector for that DCS integration. Mhm. We have a global range of customers going from Mac, from system vendors, many EPCs, a lot of OEMs, global presence for OEMs, and many end users. And we hope that soon we can collaborate with you guys, all our attendees joining today. Right? And yeah, I lost my earbud. Um, and with this, I pass it out to Bob to start our specific topic today, which again I find it very, very interesting. So it is all yours, Bob.
Well, thank you, Barbara. And this is awesome for me because I've known Barbara for a long time, but we've never actually worked together up until
Mhm.
recently. I always knew of Barbara and everything I've always heard about Barbara, and now having the opportunity to work with her directly, it's been really a pleasure. If you are here in North America, or even if you're not, you just need somebody who's really, really sharp on intrinsic safety. Barbara is a fantastic resource, and I know enough about intrinsic safety to be dangerous, but she's like a person on a lot of stuff. But of course, I grew up more on the big cast stuff, so this is going to be kind of a maybe a point counterpoint between Barbara and myself is the better solution, if you will, intrinsic safety or flameproof. And but with that being said, even though obviously this webinar is hosted by GMI, which manufactures safety relays and intrinsically safe barriers, this presentation would apply to any manufacturer, and it'll apply to any technology. So regardless of whose product you're using, it really the issues, the pros and cons of intrinsic safety versus flameproof will apply no matter what brand or anything like that. And we're not here to try to sell you on using intrinsic safety for every single application because there are many applications where intrinsic safety you just cannot use. So we really want to kind of provide you what I think is both a real world and engineering perspective as far as kind of the benefits and the drawbacks of the two different methods that are out there. So some generalities on flameproof.
Bob, I'm
Yes.
sorry. I'm going to interrupt you. Before we start, let me go over some housekeeping rules. The
Yeah.
webinar is being recorded. So please note, every webinar is being recorded. All our attendees, if you spend 75% of the time of the webinar, you will receive a certificate of attendance automatically after this event. And you will also get the link of this webinar with the material so you can refer in a future time. We do love hearing from you, and you can see your microphone is muted, but we have that question and answer chat. So please, for questions or comments, feel free to use it, and Bob and I will be checking it out as we go during this event. Mhm.
Absolutely, and thank you, Barbara, for bringing that up. And we did take there were some great questions when many of you registered. You provided us some questions and answers, and so we're going to cover that at the end of the presentation. So we appreciate those questions. And again, as we go along, if there's something that pops up that you do want to kind of find out a little bit more, and certainly we encourage you after the webinar, reach out to us, either Barbara or myself, and we'll be happy to try to answer any questions offline as well. Um, Again, getting back to like flameproof, the concept is basically containing an explosion inside of typically a cast enclosure. Now, where flameproof was actually developed was really from the mining industry, in which big, heavy cast motors were used, not so much as flameproof, but they were just designed to be big, heavy cast products. And they found out the original mining applications found out that these big heavy cast motors actually contained explosions. And the key thing was on Flameproof was it not only would contain the explosion, but the joints that were designed into the castings, if you will, acted as heat sinks to be able to cool off that hot flaming gas. So that's the whole concept of Flameproof. You have big, heavy cast walls. Typically, they're going to be some sort of cast alloy metal. They could be in an aluminum or aluminium. There are some castings done in stainless steel, different materials. Uh, and then they're typically going to be of a design where you might have a flange type design, like what you see in that picture, or they could be a screw cover type design. And again, the big benefit and why Flameproof is such a popular concept, it does allow you to use general purpose equipment such as contactors, relays, those types of products that are generally arcing devices inside of a hazardous area. It's a very common technique. In the United States, we call this technique explosion proof. And again, very, very common technique. There are some differences between flame proof and explosion proof, but they operate in the same capacity. And again, they're not limited on the energy. So again, this is a concept that is primarily used for zone one or zone two. There is actually a now within the IEC standards, there is an application where flameproof can actually be used in a zone zero application, but that's a very unique situation. But generally, zone one, zone two. Some of the advantages of flameproof, it's fairly simple to apply. We can make almost any electrical component suitable for hazardous locations. It is robust construction, and robust could be, okay, it's big and heavy. That could be an advantage. That can also be a disadvantage. It can be cost effective depending on the product involved, and it's fairly simple to combine with other techniques. So, for example, like the motor that you see there below, you could have a flame-proof motor, but you could have an increased safety terminal box. So, in many cases, you'll actually see EXD combined with other EX protection concepts to make a final product. Same thing holds true with the enclosure on the right-hand side where we have a flame-proof box and then we have an increased safety box, and we combine those to provide a single solution. So flame-proof is fairly simple. It's straightforward, and again, it's fairly well understood. Now there are some downsides of flame-proof. As much as it's widely used, there are some negative things. One of the big things that we find is obviously maintenance with regards to flameproof is obviously things like bolts. If they do not get retightened, they do not maintain, or they get lost, then all of a sudden our whole protection concept goes away because we have no protection if we have covers that are loose. Things like painting of the flameproof joints or doing any damage to the flameproof joints, scratches, even things like putting an obstruction within a dimension of a flameproof flat joint that can create pressure piling. Some of these things are things that we think about, some of them are things that we don't. Possibly the use of the wrong type of cable glands and blanking plugs, improperly installed cable glands. Again, they typically are heavy and they are in many cases difficult to service just because they have so many bolts or it's big heavy cast type enclosure. When we start making changes to the contents of the EXD box, then we can start introducing things like pressure piling. And pressure piling is where we have an explosion on the inside of an enclosure and it travels and it hits an obstruction, if you will, and we can have a secondary explosion, which could actually rupture the enclosure itself. And then finally, that U component certificate. So many people will buy these boxes without the components, and then they'll think they can just go ahead and put equipment on the inside. And they come to find out where an inspector comes in, somebody like me, and I see a U component certificate, and I realize I tell them, hey, this is not allowed because it must be an assembly certified enclosure. So these are some of the simple things that we find. And then if you look at some of these pictures, again, they can be large, heavy, very expensive. They're not necessarily the best from a corrosion resistant standpoint. You know, if we have cast aluminum, sometimes this will hold up very well, but in many cases, maybe it won't. We may require the need for sealing or barrier glands, and it does require a good understanding by the maintenance team to replace and tighten bolts, relubricate threads or flange surfaces. And it is and can be limited for the gas groups in which you're actually putting this into.
We
So
have
over on
a question on the chat. I think it's maybe good. good timing for this one. Yes, on Flameproof, is there specific nuts or bolts that need to be used, or could they be replaced for any standard bolts and nuts?
Yeah, that's a great question, and it comes up all the time. So the best thing to do is check with the manufacturer. Now, most manufacturers, they will say, they'll tell you my bolt is a A4, stainless bolt, metric M8 or something like that. As long as, generally speaking, as long as you're using the same material, same thread type, you're having something with the exact same specifications, generally that is acceptable. I don't want to tell you across the board that that is acceptable, but generally speaking, and we deal with a lot of different flame-proof closure manufacturers, and generally most of them will have that type of statement in there. So if we're going to replace them, we don't go and buy it directly from the manufacturer. Make sure that we check out the hardness, the materials, and obviously the thread type, length and size and everything else, and replace them with a like to like bolt.
And additional, the torque, right? It's very important to use the torque that is recommended or that is specified on the installation manual of these type of enclosures.
That's right. Yeah, in the Dash 14 standard, the installation design standard in the IEC world for flame-proof equipment, what it states very clearly, it must be spanner tight. However, that's the minimum requirement. You really do need to follow the specific requirements as to what the manufacturer says. So if they have a particular torque value, you do need to follow that torque value when you're reinstalling these bolts or doing the initial installation. And let's see if we can do this next one. So some of the other things that you see with Flameproof, and this isn't just Flameproof, but Flameproof equipment actually does not require to be IP rated or have an ingress protection rating. So Flameproof equipment can leak. And we do things like putting gaskets on these flanges or threads. They typically have to be done by the manufacturer. You can't just put a gasket to provide a seal, if you will, because we could potentially violating the flame-proof joint. But you see things like maybe people or maybe the glands don't fit, so we put some sort of um, insulated heat shrink, or they do have a tendency to collect water. The picture down on the right-hand side, excuse me, getting over a cold, by putting a sunshade over a flame-proof box. Well, now we've obstructed that flange, if you will. So now we've in violation of making sure that we keep a 10 to 40 mil distance between any solid obstruction and the enclosure itself. So that's a dangerous situation. Obviously, missing bolts and all that, that's another issue too. But you see in the case of the light fitting, you do see some water collecting on the inside of that. So these are all kind of the drawbacks that you see typically with flame-proof equipment. Some of the other things you'll find that's not uncommon when you start using things like barrier glands, the quality of the people that are actually doing the installation, the compound that's actually done. In some cases, like the middle picture in the top, you'll see the machining that was done by the manufacturer was actually substandard. That's not a nice machine surface. And that came straight from the manufacturer. That was not done in the field. So those types of things we have to be careful about. We want to make sure that those flame-proof joints are all nice, free from any debris. We want to make sure that they're lubricated. The Teflon tape with cable glands on the bottom left-hand side, that's an issue. We don't want to impede the flame path by the use of Teflon tape. So there's a lot of things that come into the installation of EXD equipment that we do need to take into key consideration because it's very easy to defeat flame-proof equipment if we're not installing it correctly and not maintaining it correctly. Now, some generalities about intrinsic safety. Um, Intrinsic safety is considered to be the safest protection concept out there. It's really one of only two protection concepts that's allowed for zone 0. The other one is encapsulation, MA. But it is a protection concept that has been around for many, many years, just like flameproof. And it was originally also came out of the mining industry for signaling bells, in which they limited the amount of energy for the signaling to the miners in the mines by the use of intrinsically safe barriers. And it works on the principle of limiting the energy into the hazardous area. Now, it is a system concept. This involves the use of an intrinsically safe barrier, or what we might call an associated apparatus, in conjunction with the end device and the interconnecting cables and enclosures. So this is where it gets a little bit, what I would say, a little more interesting, because it is a system concept, and we have to take that into account when we're using intrinsic safety. Excuse me, I'm getting over a cold and I apologize. Ah, one of the other things about intrinsic safety, it is limited in energy, generally 1 watt or less, generally. So it's really suitable for low power applications. Every now and then I'll see people saying, hey, I want an intrinsically safe motor starter. I want an intrinsically safe, circuit breaker panel. You just can't do that, right? It's generally low power. So a lot of our signals are 4 to 20 milliamp uh, control signals. Certainly we can make intrinsic safety, but a lot of other things we just cannot. And again, it is typically used for those control monitoring circuits and equipment, such as transmitters and sensors. Excuse me. Ah, and again, when it is selected properly, it's demonstrated to be the safest EX protection concept. One of the big benefits of intrinsic safety, it does allow the use of non-EX certified equipment within the most onerous zone of use. And it can be cost effective, and it generally is the best solution for low voltage instrumentation circuits, and there's little maintenance involved. However, what are some of the things that are problems? It does involve engineering to match the associated apparatus to the device. We're limited to the energy of the minimum ignition energy of the gas group. They can be defeated, bypassed. If we're doing Zener barriers, we require a clean earth, and then there is a requirement for segregation between IS and non-IS circuits. So what you see over in the panel on the right-hand side, you see a selection of barriers, but yet we have all different kinds of wiring going in and out, and we're defeating that, that 50 mil separation between IS and non-IS. So, excuse me, I apologize. So some of the drawbacks, we do need to match the barrier to the device, which takes into account engineering. We need to take into account the capacitance and inductance of the overall circuit, including the cable. This is one thing that people sometimes forget about. So we not only have to take into account the field device and the associated apparatus, but also the cabling itself. Again, the separation, and we really cannot repair intrinsically safe barrier units. Once they fail, they basically get disposed. However, in the case of GMI, they have a 5-year warranty. So if they fail within 5 years, then GMI will replace them.
Absolutely.
So here's an example of bypassing barriers, right? So we have some barriers, and what probably happened is maybe the fuse blew on these barriers. And of course, if the fuse blows, then there's no signal. Well, the guys in the field need to go ahead and get this running. What do? They just bypass it, right? And at that point, we have now created a very dangerous situation because we have no protection in a potential hazardous area. And what you see on the right-hand side is that, again, we see bundling between IS and non-IS. And so we could have actually a situation where the inductive currents, oh, boy, excuse me, I'm getting better, I swear. But we could have capacitance or inductance being induced into the intrinsically safe circuits. So this is something that we really have to be very careful about. So this is a potential drawback, right? This is an example of what we would call our intrinsic safety entity calculation worksheet, if you will. In many cases, we'll call this what is called a descriptive system document, a DSD. And so it takes a little bit of calculation to basically plug in all this information. And then this is how we match, if you will, to make sure that our barrier and our field device are compatible. And we're going to basically check the various parameters such as voltage, current, power, capacitance, and inductance. And as long as they all pass, then this loop is safe. But if they don't, then we can go back to the drawing.
And I think this is, again, like you were saying, Bob, we are creating a system, an intrinsically safe system, right? So you have your intrinsically safe field device, your intrinsically safe isolator barrier or Zener barrier, and your intrinsically safe, well, you wire in between that is part of this calculation to create this system that will
Right.
be installed, right? And yes, some calculation need to be done to make sure that your system will have this energy limitation, and it will be able to allow you for some of the great advantages of the maintenance uh, of the intrinsic safety system that you will be talking in a little bit. So,
Yeah.
so yeah, all these calculations need to be done ahead of time, so in the design stage. Mhm.
Yes. And this is probably one of the biggest drawbacks because people don't understand it. A lot of people, when they think about intrinsic safety, it's like, I know there's calculations, there's things I need to do. But in reality, when you start doing this, you start finding this isn't that terribly difficult. And actually these spreadsheets that you find, like for example, the one that we have here, these are readily available. There's various manufacturers that have them. People make them themselves. I have variations of these that I use at various times, and they'll take care of probably 95% of the applications. And so you can usually just plug in the information that you have from your barrier and your device and put your cable information in there, and voila, it does the calculations for you. But this is important,
Mhm.
and it is a requirement that these DSDs are provided with every IS installation, because under your initial inspection, an inspector is going to come in and they're going to ask to see a copy of this DSD. And so this should be available for every intrinsically safe loop. And this is something that those inspectors are going to want to see to make sure that it's been done and it's been done by somebody who knows what they're doing.
and
So
and I think also like for maintenance, right? Like a plant that has been running with IS for 20 years, maybe they need to replace that IS device, and that device doesn't exist anymore, right? So now they reach out to different manufacturers. Well, this information allows to be able to provide a safe recommendation on what to put in place.
absolutely, yeah, because yeah, obviously manufacturers discontinue products. And again, well, for example, as an inspector on an ongoing project, again, if what I'm going to be looking at when I'm an inspector on looking on intrinsically safe systems, I want to see this information and then I want to go validate. I'm not going to go and double check all the numbers, but what I am going to do, I'm going to say, hey, is that equipment that's out there, does that match what's actually on this? Is the field device, in this case, that particular brand of product? Is this the particular associated apparatus? Is that all correct? So, and if we decide, hey, we can't get this product anymore, we want to modify it or we want to change it, then that's okay. Then all we need to do is just update our DSD and we go on down the road. So this is it should be a living, breathing document that stays with that intrinsically safe loop for the life of this installation. Could be 30, 40 years. And so it's something that is important to have, where again, this is how we validate that intrinsically safe installation.
And we have a question from our attendees. It says, for design team, it's a bit challenging to select the right type of IS barrier and get the information to be added. For this type, manufacturers like GMI and many others, we're we want to partner with you to help on the safe selection of these devices. So you just reach out to us, reach out to partners like Source IEX, distributor partners for this type of applications, and that's what we like doing, right? Give us the application, and then we can work together to see which one makes more sense, which product makes more sense for the application. Because just like the attendee was saying, there are several different barriers. Which one do you select, right? And there might be five different options that will work, but it really depends on the application, on what you want to achieve, that will help us guide you, towards one versus the other. So
Yeah,
definitely partner with us, partner with IS specialist
yeah,
for that type of support.
yeah, yeah, absolutely. And it can get confusing. A lot of times what manufacturers of say end devices. So if you look in a Rosemont catalog or something like that, and you look at their installation operation manual, in the very back, they'll actually give you a specific brand or manufacturer. That doesn't mean that you couldn't use another brand or another manufacturer. It just means that they've done the research to kind of do some calculations and said, hey, if you use this brand, this manufacturer's product, this one will work. If you use this one, so forth and so on. A lot of times that's pretty common. On the other hand, a lot of engineers and designers want to actually do an evaluation themselves because again, the manufacturer may be pushing a particular brand. Maybe they really like working with those guys, but maybe it's not the best performing product. And it could work against and for companies like GMI. So, sometimes GMI is on the list, sometimes they aren't. Sometimes it's the other guys. So, but that's a good place to start. Start with the manufacturer of the field device, see if they have recommendations. But if they don't, then certainly reach out to, us, reach out to somebody that does this, and we can certainly make some suggestions and ideas and recommendations.
And I will add, Bob, something that I find really good about the NEC, that in North America, for North America standard, the any intrinsically safe device needs to have a control drawing, and the
Yes.
control drawing is a beauty. It is so well. It explains very clearly how you need to install that device to be,
Yes.
aligned with the standard. So, all if you're in North America, you're following class division installations, always refer to the control drawing, uh, also for additional information.
Yeah.
Good. So we have a poll question. Okay, uh, let me find it here.
Let's see.
This one.
You know,
Yeah.
got it?
Yes, I think yes, I can see some answers. So let's
So
see
see if you were
how.
paying attention here. So what zone of use can an EXIA product be installed into? What's the best answer?
I think this is a little bit of a trick question.
It's a little bit of a trick question. A little bit, yeah. And I will share with you while you guys are going through this. When we teach a lot of the certification training, we're a complex, as Barbara said, we teach complex and we also teach the IECEX Certificate of Personnel Competency Program. And you will see that the questions like this are kind of written in such a way to where they kind of throw you off a little bit. So you might think, okay, this is the right answer, but then there's kind of like, well, wait a minute, I got to think a little bit. So some of these questions can be a little bit tricky.
Mhm. Okay, so we have, I think the majority of our attendees have answered now. So
Madam
let's
Chair?
see. Let's end the poll. So was it C?
It was
Zone,
C.
zone 0, 1, and 2? Uh-huh.
That was the most correct answer. And zone 1 and 2 is correct. And zone 20, 21, and 22, those are dust hazards. Intrinsic safety can be used in those. It's just not as common. So really, the only one that's really wrong is the fourth one, zone 0 only, because if a protection concept is suitable for the most onerous zone, by default, it's good for lesser zones as well. So in that case, the correct answer would be C.
I will have to put C and B if I was allowed to do two,
Okay, there you go.
two options.
No worries. So what standards provide the guidance for the use of flameproof or intrinsic safety? So the installation design standard for those in the IEC world is within the Dash 14 standard. Complex IS circuits are located in the Dash 25 standard. Within the US, we do follow the NFPA 70, which is commonly referred to as the National Electric Code, and that's all in Article 504. In Canada, we follow the CSA C22.1 Part 1, Section 18. And there are also some other documents that you can find for installation design, such as American Petroleum Institute recommended practices, or the US Code of Federal Regulations, or even again, some of the other international standards that are out there. The good thing to note is really positive is that both of these protection concepts are pretty much recognized worldwide, and almost every country's regulation standard with regards to the design pretty much have similar or exact requirements for those two protection concepts. So the positive thing is if you're familiar with intrinsic safety in Europe and you want to apply intrinsic safety in, say, Latin America, guess what? It's pretty much the same. We want to do it in the United States. Well, we're slightly different because we do have the division concept, but if we use the zone concept, then it's pretty much the same. And again, almost everywhere else in the world, the concepts for flameproof and intrinsic safety are very, very similar no matter where you go.
And we see that a lot with our OEMs customers, right? Taking advantage of that one design that they can utilize pretty much in any part of the world because they can triple certify it, right? Or quad certified an assembly. Hmm.
Yeah. And so really then it boils down to, okay, well, what about the cost of ownership? And of course, there's the financial outlay. Again, there's certain applications where we can only use flameproof. There's certain applications where intrinsic safety makes sense. And there's certain applications where we can do either one. So just picking out a simple example here, just taking a look at the cost of doing, say, a transmitter. And in this case, we've got a flameproof transmitter. Let's just say this transmitter is $400. It's probably a lot more, but anyway, if we use $400 as a basis in US dollars, okay, then in that case, generally we might have to use a barrier gland, possibly not. A barrier gland is a compound type gland. Depending on the cable type, depending on the cable length, depending on where we are in the world, we may not need to use a barrier gland. But if we just assume we do, and then we're going to use, say, an armored cable, a braided marine type cable, or maybe a steel wired armor cable. This is kind of what we'd be kind of expecting, if you will, for a cost of a traditional flameproof type installation. Now, if we do the exact same thing and we say, well, look, we're going to do it instead of doing it flameproof, we're going to do this as intrinsic safety. Well, again, the transmitter is going to be basically the same cost associated with it. Really, the difference in the cost now is going to be with the gland, the cable, and certainly the associated apparatus. So there's, depending on the length of cable, depending on how many of these loops there are, this can be a fairly cost-effective solution, but it really just depends on, again, how many loops you have, how much cable. Cable is going to probably be the major factor why one installation could be less expensive than the other. Because when we start running with IS cables, now all of a sudden the cable requirements, we may not require to use an armored cable. And then even in many cases, the glands that we use for intrinsic safety, in some cases, they don't even need to be certified. So there can be some significant cost savings in going with a flameproof installation versus intrinsically safe. And what does make it interesting is that you will find that the end users now are making a lot of their devices, such as transmitters, that they'll be marked both for EXD and for EXI. So you have the choice. It's up to you how you want to install this. And it's really important too to make sure that if you're doing it one way or another, that the people that are doing the installation understand how you're doing it. And then, of course, if you're doing it as intrinsic safety, then we do need to have either that control drawing or that DSD to be able to validate that. And that's really important. So again, material cost transmitter is the same. Cables and cable gland would be generally less, but we need to include the cost of the ISB. Generally, the longer the cable run, the more cost effective it can be. Maintenance cost. All EX installations shall be inspected once every 3 years. Flameproof may require de-isolation before opening and closure if a full detailed inspection is required. IS loops can be worked on while energized. However, that being said, many plants, many organizations do not allow IS to be worked on while energized, but the standards generally do allow you to do that. So the key thing on intrinsic safety is that after that initial detailed inspection is done, if it has been done and everything has been selected correctly, the only real inspection that we're doing is making sure that nothing has changed. That's really the key thing, making sure that the environment is not degrading, say, the cable, the transmitter, or whatever it is. That's really our key thing. So there's, generally speaking, on intrinsic safety from a maintenance, from an inspection standpoint, generally it's a fairly simple, quick process, just making sure that, again, it matches what was originally done. I think we have another poll question here, Barb.
Yes, we see it. Intrinsic. I see. Let me find it here. Okay.
While you're doing that, we had a question regarding EXD cable glands. Is correct to use a barrier gland until 3 meters of cable distance? Question mark. Beyond 3 meters, can I use a normal armored or non-armored cable gland, for example? Yes, to an extent, yes. The 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 addition of the IEC 60079-14 from 2013, they had this 3 meter rule, where basically going into a flame-proof box, um, if the cable was circular, compact, had extruded bedding, basically would not allow gases or vapors to travel in between the cores, then we could go and not use a barrier gland if the cable run was longer than 3 meters. Now, that standard has just recently changed and it's been introduced in, I think it was October of this year or last year, and it's now been introduced as Edition 6. And that 3 meter rule has changed. So we'll probably talk about that sometime in one of these webinars, but there's a new cable gland selection chart for EXD, or actually primarily for barrier glands where you need to use barrier glands, and it's not the 3 meter rule anymore.
Good. Okay. So our attendee has responded. I think they did pretty good. Right? Limiting the amount of energy that
Yeah,
can be released.
there you go. Yeah. So quenching or cooling of the gas vapor, that's flame proof. Removing the explosive vapor from relevant surface, that's a pressurization concept. Eliminating or reducing the heat or sparks in a hazardous area, that's considered to be increased safety. So yeah, limiting the amount of energy is the concept. So again, when we start looking at some of these things, we start noticing that products will have multiple certifications to be able to install them in different fashions. So in this particular unit, I can install it either as an EXD product, I can install it as EXIA, or I can even install it as EXNA, which is now known as EXEC. So it's really important to understand how are we installing this, making sure that we follow the right requirements for the protection concepts and that we're selecting the appropriate cable glands, or if we're doing it from IS, then making sure that we're selecting the right associated apparatus or barrier for providing our protection. And there you see on that label, you'll see those entity parameters. That's where you'll find that information. Those entity parameters will also be listed on that certificate. So that's where we get all that information to be able to plug into our calculations to be able to match the barriers. So again, some of the deciding factors, again, cabling and cable glanding can be a big issue. Uh, again, I don't want to minimize, you don't always have to use barrier glands, so that's not necessarily always the case, but certainly glanding seems to be a big issue with regards to any EX installation, regardless of what it is. But, certainly glands are very, very important. Again, each concept has its advantages and disadvantages. And again, sometimes the advantages of one versus the other is not so clear. Each installation situation is different. It depends on the labor force and the skill of the operator technician, including the designer, because it can make a big difference of whether or not that protection concept makes sense. You know, one of the things I'm working with a customer right now that's doing a project in the Middle East, and they're going to use intrinsic safety for the first time. And the good thing was from their design, a lot of their equipment were considered to be simple devices, sensors. And because they're simple devices, not energy storing, then really their installation, their design of their packaged equipment is more or less doesn't have to change because with simple equipment with intrinsic safety, we do not necessarily have to have certified pieces of equipment. We can use general purpose equipment with intrinsic safety. So that's a big factor for them where their design, for the most part, doesn't really have to change dramatically, the parts and pieces and everything else. So again, for some generalities, such as Zone Zero, the only real solution is intrinsic safety. And again, for power installations, IS won't work, and flameproof or pressurization or some of the other techniques may be the only choices. Now, this is one that we didn't cover. I tell you what, we're kind of running out of time. So, Barbara, I'll just give the answer on this one.
Okay. Yes. Mhm.
So a U at the end of an EX certificate means, and I think I did mention this, but this means that the equipment has a component certificate only. So that's typically a terminal block or maybe just a little switch or maybe even a ballast in a light. That's going to be a component certified product. That means that we cannot use that product unless it's been part of an overall assembly and it's certified as a complete assembly. So that's where the U comes up into place. If I'm a designer and I'm looking to use these types of products, I want to make sure that my product, if it has a U, is part of an overall assembly, and I'm not just using it as a standalone piece of equipment, because that's going to be a problem. It's going to have to undergo additional certification. Now we do have a wall chart, and Barbara and I actually, we talked about this. We have a functional safety wall chart, but we also have a very nice hazardous location wall chart available, and it is free of charge. I don't know if we send it out automatically, Barbara, but if anybody
It's Yeah, I'm not sure either, but it's on the website. You can always reach out to me. On the GMI website, we have all the supporting documentation. We also have an anti-parameter tool revision. They will help you to do that anti-parameter matching. So definitely spend some time on the website. Take advantage of that supporting documentation we have created for you guys.
now don't leave.
We're not done yet.
Not just can't leave yet. Well, of course you can leave, but we did want to at least address some of the questions that you have brought to us. So, first question, must the equipment and barriers be certified as intrinsically safe by the authorities regulators? Yes, for the most part. However, the barriers in some of the final end devices must be certified as intrinsically safe. However, this is important to know. A barrier itself, the associated apparatus, is not intrinsically safe, but the output is. So now the field device may or may not need certifications as being suitable for EX applications. If it is a simple device, basically a non-energy storing device, such as a switch, an RTD, that device would not require EX certification. So in those instances, we can use general purpose equipment, including in some cases the wiring methods that we would employ for a non-hazardous application when we are using intrinsic safety. So that's probably one of the biggest advantages of intrinsic safety is that, again, if we have simple devices that are non-energy storing, and we can pretty much follow almost the exact same installation for a general industrial application in the most onerous hazardous location application. And that's a very big benefit for using intrinsic safety. Are IS calculations required in any IS installation? Yes, absolutely. You can't really realistically use IS and be assured of its safety unless you properly match the barrier with the end device. And again, you may find that you're not able to provide enough power to run that device, or you may find that the parameters will exceed that of the minimum ignition curves. Regardless if it's called a DSD or control drawing or whatever it may be referenced into your country, it must be done. Okay. Now, it can be done by a manufacturer, a designer, third party, as long as that person or organization is to do so. So it shall be done. It has to be done. How it's done is left up to typically country-specific regulations, but it does need to be calculated. In this one, what are some of the key differences between countries, regions with regard to IS and flameproof? And again, for the most part, we talked about this a little bit, but the countries follow the 60079 in Europe. They follow the EN versions. In the US, we follow the UL versions. In various other parts of the world, they'll have a various variation of the 60079 standards. The 11 standard is the intrinsic safety standard. 14 is the design and installation, which includes intrinsic safety. And 25 is the standard for complex intrinsically safe circuits. So those three standards are kind of where we go to find out all of the details with regards to intrinsic safety. In flameproof, the same does apply as well. For the most part in the world, we follow the 60079-1 standard. In the US, however, we do have that concept called explosion proof. It requires a higher pressure testing than flameproof. So there is a difference between explosion proof and flameproof, but the concept is the same, if you will. What's the biggest issue with IS? Well, again, all the other protection concepts recognized in the IEC world are pretty much standalone. But IS, as we mentioned, it is that true system concept, which does require engineering taking to effect the end device. And it can be defeated in the field by bypassing the associated apparatus. And again, this is one thing. Lastly, since some people don't understand it, fortunately, it isn't touched, which in some cases is an advantage. So people think, okay, flameproof, I can just get in there and I can open it up and then I tear it all apart. And then they think, yeah, I understand this. Intrinsic safety, people don't understand it, so we don't want to touch it. It's kind of like black magic, so to speak. So I don't know if that's an advantage or a disadvantage, but that seems to be the case. I notice that, if a barrier blows with a Zener diodes or a fuse blowing or something like that, uh, they just don't want to touch it. They just replace it and then just leave it alone. So where does it outperform flameproof in real world use, especially for OPEX and maintenance? Also, how does it impact PLC design, high power limits, and hard communication? That's a good question, right? The OPEX, or the operational cost of maintaining the system, can be significantly less than using traditional flameproof systems. Flameproof can be easily compromised by the environment, such as corrosion, poor maintenance processes, or lack of knowledge, or replacing the tightening bolts and other factors. Um, Generally, IS systems, and again, these are generalities. Every application is going to be different. I don't want to just make a blanket statement to say that every case is going to be the same way. But generally, IS systems, when they're properly designed and selected, are not subjected to the same inspection requirements and maintenance procedures that you might find with flameproof equipment. Again, one of the big benefits of IS systems, we can do our inspections and maintenance on IS systems without de-energizing the circuit. So generally speaking, from a maintenance perspective, um, and again, the materials that we use for intrinsic safety, we can use different corrosion resistant materials where on flameproof, the materials we may be limited to cast metal, which again, in some cases, depending on the environment, could be a negative where, corrosion could affect its long life.
And I would like to add here as well, Zener barriers were really a challenge for for the energy limitation when you would put it between the PLC and the field device. But nowadays, with galvanic isolator barriers, they are designed to be in between the field device and the PLC, or the field device and the DCS. So they are optimized for that type of loops. So
Yeah,
so now, I mean, it's way way simpler with the with the new technology to work with galvanic isolator barriers. Mhm.
yeah, yeah, no doubt, no doubt. And actually, this was I've seen a product marked with a slash in the marking string. So this isn't necessarily kind of completely part of what we're talking about, but what does that mean? And it's something we don't see too terribly often, but I'll give you an example. So this is where a piece of EX equipment could actually be located in two different EPLs or two different zones. So we could have a zone zero. We could have where the sensor is located in a zone zero, and maybe the electronic compartment is located in a zone one. So the marking of the product would be down in the bottom there, where it says EXIA 2C T6GA slash EXDB 2C T6GB. So we actually are incorporating two different protection concepts. But in this case, that particular single unit would have half of it installed maybe in a zone zero, and the other half of the unit would be installed in a zone one. So that's a little bit unique. We don't necessarily see that all the time, but I say it's unique. It's out there. It's not completely unused. It's not completely unique, so to speak. I guess what I'm saying.
And I think that's also how, I mean, now manufacturers, when designing equipment that are going to be in the hazard location, they optimize, right, this equipment by mixing protection methods to make it
Yeah.
easier to install, easier to maintain. So we're starting to see more of this type of, yeah, different protection methods utilizing one item.
Yeah, and that's true. You know, you see those, like, for example, we showed that one housing that had different, you could install it as EXD, or you could install it as EXI, or you can install it as EXN. So it does make it more important now than ever that the individuals that are responsible for the design of the system to truly understand how are we going to use this product and make sure that we share that information, that we select the appropriate wiring methods, uh, we select the appropriate glands, we select the appropriate cable, because it used to be it was fairly simple, but now manufacturers are making one product that can be used anywhere, and they're putting more and more onus on the operators themselves to make that proper selection. So the knowledge of what people in the EX field, we need to step up our game, because manufacturers again are trying to make one product that can fit everything. And so we need to be very cognizant of that fact. For IS installations, what cable glands do you recommend? So without giving brands or anything like that, this is actually out of the latest standard. This is out of the Dash 14 from 2024. This is table 15. So what you'll see down there for EXD, what we have to use is an EXD gland. If you notice there for EXI, we can use an EXD gland, we can use an EXE gland, or we can use an EXN gland. And in some cases, we can actually use a non-certified gland as well. So for intrinsic safety, we have a lot more flexibility as far as the type of cable gland that we can use. In many cases, people can use, say, just plastic EXE glands. They could use brass. Uh, we're not as the requirements are not as rigid, because an EXD gland has to be able to withstand an internal explosion, where an EXI gland does not. And by the way, you notice that there really isn't such an animal such as an EXI gland. There are cable glands that are marked blue, or blue cable glands, but generally speaking, they're really not EXI. They're actually EXE. Um, Although I know some manufacturers have actually gone to the extent of actually getting their cable glands EXI, but in reality, they're actually just EXE glands that are marked blue or colored blue, so to speak.
And again, that's, I think, one of the great advantages of doing the intrinsic, I say, system, because the cable is part of the entire system. You have that IS loop, and that's why you have this flexibility on the material you can use, like the cable glands and the actual cable.
Yeah.
Mhm.
I think this is the last one. I'm not sure. I know we're kind of at the
Oh,
end here.
mhm.
Uh, I have a linear heat detector. If this is installed with an intrinsically safe barrier, does the heat detector need certification? Well, it really just comes down to the fact that is the heat detector a simple or non-simple device? And it is defined in the Dash 14 or 25 But generally, in simple terms, that the device has the ability to store energy in the form of capacitance and or inductance, then yes, this heat detector would need to be certified as intrinsically safe. So if it has a printed circuit board on the inside of it, chances are it would need to be certified. Um, oh boy, this is another one. What are the biggest misconceptions about IS mistakes have you encountered? Well, just to briefly go through this, one of the things I always find when I see intrinsically safe, I was doing an inspection last month and I came across an intrinsically safe installation. The first thing I asked, I said, can I see your descriptive system documents? And they looked at me like I was from Mars. And I said, well, this is what it is, and I need this. And so in many cases, people do not actually have that. So it's something that, I do, and I'll generate that for them. But generally, that would be something that, we would ask for. And hopefully, anytime you're doing intrinsically safe, you've generated those DSDs. Bypassing the ISBs in which the fuses are blown, that's pretty common. Not maintaining that segregation between IS and non-IS circuits, replacing one with another without doing those calculations, and not taking into account the cable type and the length of the cable run is that can add to the overall capacitance and inductance of the circuit beyond the safety factors. Those are probably the biggest issues that I see with regards to intrinsic safety. I think I made it. Oh,
Yes, yes. So thank you, Bob. Absolutely, we have several webinars coming up. So again, spend a little bit of time on our website, gminternational.com. We also have a YouTube channel with all these and many other great webinars that have been recorded. So you can go back and refresh your memory with some of these. And we really thank everyone for your participation on this event. We see a lot of questions. We'll go over those probably after this event, and you will be getting an email with the certificate if you stay more than 75% of the time, and with the recording. So I guess it's the last poll. Let us know how we did, or how Bob did. Um, and again, thank you, Bob, for sharing all this knowledge with me and with the rest of the attendees today.
Barbara, thank you. And as I like to tell people when I used to do these with Paulo and myself, I'd always say, well, if it was excellent, it was me. If it was mediocre, it had to be Paulo. So that was my take. So, and I apologize for my cough, but please don't hesitate to reach out to either Barbara or myself if you have any questions. We're here to help you, even though we are in the United States. We know a lot of people from around the world are tuned into this, and we love hearing from you. Don't hesitate to reach us, and we'd be happy to get a hold of you or get back with you and answer any questions that you might have.
Perfect. Well, thank you so much, Bob. I hope you feel better soon,
Yeah, well, you
and we'll see each other one of these days here in town.
too. Thank you, everybody. Bye bye.
Bye.